Hello everyone, let's talk about geometric probability. So before we talk about geometric probability, let's just do a quick refresher on probability. Probability is the likelihood of an event occurring. The notation we use for probability, it's generally P, and then it's an empty parenthesis. Inside the parenthesis is the event you want to occur. So probability is a ratio. It is to tell us how likely something's to occur. So in the numerator, it's the favorable outcomes. And in the denominator, it's the possible outcomes. So if in general, just a very, very simple case, if we had 3 red balls in a jar, 5 green balls, and then 6 blue balls in a jar, and we want to find the probability that a ball chosen at random from the jar is green. Your probability of green, well, the favorable outcomes is 6. Oh, sorry, not 6, that's blue. The favorable outcomes is 5. And then the total outcomes is 14. So it's 5 over 14. So this is an acceptable way to express probability. Another acceptable way is to write it as a decimal. I don't know what 5 over 14 is off the top of my head. Hold on, let me just grab my calculator. So it's 0.357. Or we can write it as a percent, 35.7%. These two are the primary uses. Very rarely are you going to be approximating it as a decimal and not converting it as a percent. Most of the time your probability is going to be expressed as a percent or as a ratio. All right, so that's general probability. What geometric probability is we're talking about, instead of objects or instead of general events, the events are specifically points in a geometric figure. So if we had a triangle, and in that triangle we had that shaded region, and we were told that this was 2, 4, and 4, we could find out the probability of a point in the triangle being in the shaded region. So to find that, oops, forgot my equal sign. For geometric probability, the possible outcomes would be the area of the shaded region. And the favorable outcomes would be the area of the shaded region. The possible outcomes would be the total area. So in this case, well, all of them have the same height. And that's 10. So the area of the shaded region, it's 1/2 times 4 times h. 1/2 times 4 is 2, so that's 2h. And the area of the total region, it's 1/2 times 10 times h, so 5h. The h's divide off, so the probability is 2/5, or 40%. So that's probability. So that's a case of probability. Now, there may not be just one shaded region. let's say we had a circle inscribed in a square, so pretend that touched. And then there are concentric circles inside. And let's say this represented a target. Inside here is worth 1 point. Inside here is worth 2. And inside here is worth 3. And each circle's diameter increases by 1. So that diameter is 1. That diameter is 2. And that diameter is 3. We could be asked to find the probability of hitting that target, and the whole target is really the square, just these are worth 0 points, and getting an odd number. So this could be a case where we have 2 regions that we need to check, because the favorable would be here and all out here. So it would be these 2 regions over the whole thing. It will be the probability of the area of the 1 and the area of the 3 over the area of the square. Well, the area of the square is easy to find. It's a square with a side length of 3, so that's 9. The area of the 1 is easy to find. The radius is, well, the diameter is 1, so the radius is 1/2. So it's 1/2 squared times pi, which is pi over 4. The area of the 3 is a little harder to find. It's got a radius of 3/2, but it's also got this radius of 1 removed from it. So that's 9 pi over 4 minus 2 pi. Oh, sorry, not 2 pi, just 1 pi. 1 squared is 1. Silly me. So I'm just going to continue down here. Denominator of 9 pi over 4 plus, and 9 pi over 4 minus 4 pi over 4 is 5 pi over 4. So that's 6 pi over 4, which is 3 pi over 2 over 9. The 3 and the 9 divide off. That's pi over 2 over 3, which is pi over 6. So that's the probability of getting an odd score. All right. So that's just geometric probability in general. It's the area of the favorable part over the total area. And that's how you find geometric probability. All right, have fun.